Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Okay, hari ini saya bersama Alif dan saya Fakir. Okay, untuk soalan 1, 2, 3 tak perlu present, tapi untuk soalan 4 dan yang kelima ni kami ditugaskan untuk present. Okay, yang pertama sekali adalah soalan yang keempat. Okay, soalan keempat ni elaborate on each of the conic section, which is definition, technique of graphing, etc. And you need to give example of question in your elaboration. Okay, first sekali adalah circle. Okay, a circle is a set of points in a plane that are equidistant from a fixed point. The distance is called the radius of the circle, and the fixed point is called the center. Suppose a circle has center, which is k, and radius r greater than 0. Okay, kat sini kami sertakan contoh dia. Yang pertama, example 1. Find the center radius of the equation of a circle with radius 6 and center with coordinate -3, 4. Graph the circle and then give the domain and range of the relation. Okay, solution ni kami sertakan by using the center radius form with h equal to -k and h equal to -3 and k equal to 4, while r equal to 6. We find the equation of the circle is given like this. Okay, then the graph is shown in below. Because the center is -3, 4 and the radius is 6, the circle must pass through the 4 points. Okay, which is -3 plus minus 6, 4, and -3, 4 plus minus 6. As illustrated in the table, using these 4 points, we see the domain is -9 and 3, and the range is -2 to 10. Okay, itu adalah satu contoh untuk circle. Okay, seterusnya untuk ellipse. Okay, an ellipse is the set of all points, which is x, y, in a plane, the sum of whose distance from two distinct fixed points, which is foci, is constant. Okay, the line through the foci intersects the ellipse at 2 points called vertices. The chord joining the vertices is the major axis, and its midpoint is the center of the ellipse. The chord perpendicular to the major axis at the center is the minor axis. Okay. For example, ellipse. Okay. Find the standard form of the equation of the ellipse shown in figure below. Okay. For the solution, first from figure, the foci occur at -0 and 2, 0. So the center of the ellipse is 0, 0. The major axis is horizontal and the ellipse has an equation of the form as you can see there. Okay, also from the figure, the length of the major axis is 2a equal to 6, so a equal to 3. Okay, moreover, the distance from the center to either focus is c equal to 2. Okay, finally we have a equation which is b squared equal to a squared minus c squared equal to 3 squared. Then minus 2 square equal to 9, minus 5, and until we get 5. Okay, substitute a square equal to 3 square and b square equal to 5 square. Here the equation is standard form. Okay, as you can see there. Okay, that for example for ellipse. Okay, next we continue for parabola. Okay, for parabola means a parabola is the set of points x, y in a plane that are equidistant from a fixed line. The directrix not on the line. The midpoint between the focus and the vertex is the axis of the parabola, as you can see there for the parabola. Okay. Okay, this picture means the standard form of the equation of a parabola with vertex 0, 0 and directrix y equal to -p is given by this equation. Okay, for directrix x equal to -p, the equation is given by y y square equal to 4px, which is p never not equal to 0. This for horizontal axis. Okay, the focus is on the axis p units, which is directed distance from the vertex. Okay, for example, for parabolas, the question is find the focus of the parabola whose equation is y equal to negative 2x squared. Okay, for the solution, okay, because the square term in the equation is above x, you know that the axis is vertical and the equation is of the form x squared equal to 4py. So you can write the original equation in this form as follows. Okay, x squared equal to negative half y, turn into x squared equal 4 multiplied by negative half y. Okay, so p equal to negative 1 over 8. Because p is negative, the parabola opens downward, and the focus of the parabola is 0, p equal to 0, 1 over x. Okay, therefore example for parabola. Okay, next, hyperbola. A hyperbola is the set of all points, which is xy in a plane, the difference of whose distance from two distinct fixed points, which is foci, is a positive constant. Okay, the definition of a hyperbola is similar to that of an ellipse. The difference is that for an ellipse, the sum of the distance between the foci and a point on the ellipse is constant, whereas for a hyperbola, the difference of the distance between the foci and a point on the hyperbola is constant. Okay, so the standard form of the equation of hyperbola with center at the origin, where a equal to 0 by p equal to 0 is given by, okay, as you see there for the equation. Okay, for example, for hyperbola, okay, example 7, find the standard form of the equation of the hyperbola with foci at negative 3, 0 and 3, 0 and vertices at negative 2, 0 and 2, 0 as shown in figure below. Okay, for the solution from the graph, you can determine the c equal to 3 because the foci are 3 units from the center. Moreover, a equal to 2 because the vertices are 2 units from the center, so it's followed that, okay, b equal to c squared minus a squared, okay, become 3 squared minus 2 squared, so 9 minus 4 we get 5. Okay, because the transverse axis is horizontal, the standard form of the equation is given by this, okay, as you can see there. Okay, finally substitute a squared equal to 2 squared and b squared equal to 5 squared to obtain this. Okay, that's for question number 4 for ellipse, center, hyperbola and parabola. Okay, next we jump to question number 5. Okay, I pass to Muhammad Ali bin Muhammad Jamil.